Hi everybody, this is Mr. Defali again. I wasn't able to finish my last video because of time, but I thought I would come back and finish what I started. So this video will be actually very short because it's just the end of the last one I posted. But I wanted to cover two graphs that look almost identical with one exception. And if you haven't caught on to what that is by now, then no worries, I will point it out later. But in our earlier video, I was talking to you about, you can see over here, talking to you about domain and range and how to write them in both set notation and also as a compound inequality. And I gave you two examples, as you see right there. And I want to conclude it with these two examples over here. Now, what's interesting about these two examples is, like I said earlier, they look almost exactly alike, but there is one exception. One exception, and I don't know if you caught on to that by now, but you will in a moment if you haven't seen it yet. Anyway, I'm babbling, so I'm going to go ahead and get right to it. So let's get right into the domain for this. The domain for this in set notation would start here at the left side. You can see this is at -4, and it runs all the way down, it loops up, and then it stops right here at +4. So how do you write all this in in set notation? Well, the way to do it is by using the numbers that I just pointed out a moment ago, which are -4 and +4. I'll circle that again. Now, if you were to take these points and just drop it straight down, what you would see is that these numbers, -4 and +4, contain the entire graph from left to right. So everything from left all the way going to the right and then stopping, and vice versa, going backwards again, is contained between those two numbers, -4 and +4. So that will be the focus of my domain. So it goes like this: -4, comma, +4. And like I said earlier, because these points are closed at their locations, they each get a closed bracket or a bracket. I can write the same thing with a compound inequality, and it would look like this. So it would still be -4 and +4. However, I would have to put my x in the middle because, again, x represents a domain. It's another name for input. It's another name for independent variables. So there's my x in the middle, and this is saying that all the x's contained on the graph over here lie between -4 and +4. And to show that they lie in between, I have to put these inequalities. Now, when the point at the beginning, and I'll zoom in here so you can see, when that point is closed, as you can see right there at the -4, that means you're going to have an inequality with that extra bar at the bottom. Same with this one. This is where it ends, see, at +4. And so that will also have an extra bar at the bottom. So that's why I'm putting it like that. And that is your compound inequality for the domain. And I can do the same thing for the range. So range, first set notation. Okay, so set notation for the range. Now, for the range, I'll get rid of these here, and I'll get rid of these here. The range is about how tall this thing is. So when you might want to measure the height of something, you measure it from the very bottom all the way to the very top. And so doing that means I have to go to the lowest point, which is down here. That's the lowest point. And then go to rise to the highest point, which is all the way up here. So the height of this thing is from there to there. So in terms of the numbers on the y-axis, where would that be? From where to where? Well, if you go straight across, you can see that our lowest number on the y-axis is -2, whereas the highest number on the y-axis there for our highest point is a +4. So lowest number, -2, highest number, +4. And so that's what I will base my range on. So coming back over here, I can say, well, my low number is a -2, My high number is a positive 4. And once again, like I said before, because this is closed here, there's no break over there, and there's no break over there. It's an open dot, a closed point. That means they each get a bracket. So one there and one there. Okay, and I can once again represent this as a compound inequality, and it would look like this. So I would still have -2, and I would still have positive 4. This time, however, because I'm dealing with the range, and as you can see, the range is all the numbers on the y-axis, that means the middle part needs to have a y. And to show that the entire graph is between -2 and 4, you just put these inequalities like that. And again, it's less than or equal to because my points here are fully closed. And that's it. So that's set notation over here. Set notation. And over here, we have a compound inequality. Compound inequality. And it's the same for the range down there. All right, well, let's go ahead and do the other one. And if you haven't figured out yet what the difference is between the right graph and the left graph, here it is. So the right graph has this arrow right there, whereas the left graph, it's not there. Well, what's the difference between that one and this one, you might be thinking? Well, I'll tell you. The difference is that arrows represent going on, continuing, moving along. And they keep doing this forever, basically. On a graph, you never run out of space because your coordinate plane is exactly that. It's a plane. And for those of you who are in geometry, you might know or remember that a plane stretches for infinity in all directions. So this arrow means that this graph, and I'll trace it for you here, this graph is starting here at -4, just like before. Starts right there. So it moves to the right, it dips down, swings up, but rather than stopping at that point like it did last time, this arrow means it just keeps going up and up and up and up and up, and it just never ever stops, ever. So we have to represent that when we do our inequality and our set notation this time. And it's pretty simple to do. It just takes a little change in our symbols. So let's start first with domain, just like last time. So domain, so I start at -4, just like before, okay? And this takes a bracket. However, rather than stopping at 4 like I did last time, remember last time over here, I stopped at 4 because the graph stopped at 4. But not this time. So instead of doing it like that, I have to show that this graph will continue to going to the right and going to the right and going to the right. As long as this thing climbs up, it'll always move out to the right further and further and further. And it will never stop. So to show never stop in math, all we use is this lying down kind of lazy 8. And it looks like this. It's called infinity. And because the graph will move on toward infinity, rather than using a bracket, I must use a parentheses. And parentheses mean that it will not stop. Okay, so think of a parentheses as something bendable, like rubber, like it kind of wobbles back and forth. But a bracket is strong and steadfast, and it will not yield to anything. So it starts at -4, goes to infinity, and it just moves on from there to positive infinity. Now, how do you show this with a compound inequality? Well, basically the same way. So you still have -4, you still have positive infinity, however, your x is in the middle, and you show a less than or equal to for -4, but here's the thing, for the infinity, because it doesn't have an end, you put less than, but you don't put that bar at the bottom. okay? Because infinity just never stops, and you'll never reach the end of that. So this is always going to remain open, whereas this side always remains closed. And that's the domain. Now the range works in the same way. So range, and once again, it'll look very similar to what we did over here for the other graph, but keep in mind, unlike this one here, where it has a clear end right there, unlike that one, this one will not end, and in fact continues on forever, just like it did for the domain. So for the range, it's a little easier to visualize because this arrow is pointing up instead of sideways. So once again, we go to the lowest point, which is at -2. And so we put that here, -2, brackets, because it is closed at that place. And it climbs on forever. So infinity and parentheses. And we can represent this again with a compound inequality. And it would be this. So it would be -2, forever, infinity. Y goes in the middle because we're dealing with the range or the y-axis, the output numbers, all the dependents, etc. So y goes in the middle. Less than or equal to for the -2 because that's a solid point on this graph, as you can see. Bam, right there. That's a closed point. No breaks, no interruptions at all. That is not going anywhere. But it's going to climb forever. And because we cannot pinpoint the end of forever, we will use less than but no equal to. Okay? No equal part to that. And that is domain and range for both of these graphs. And you can see the difference in the symbols that we use, both with the infinity sign and with the use of the parentheses instead of using the brackets. So there it is, folks. I hope this really helped you out and helps you when you're doing your homework for tonight. Please post any comments or questions that you have. I will try to get to them before the next time we meet. If I don't, then please bring them up in class. Remember, you can always post a note on our question wall. And I look forward to seeing you all again. Take good care. Bye-bye.